This is scientific notation. Some of you are very good at this. It's easy for you. I'm going to try to make sure I explain it in a way that will help you. All right, example 1. We're going to write this in standard form. So what's important now is when you read your instructions and it says write in standard form, what does that mean? It means write an actual number that you guys understand. We're not multiplying by 10 raised to some power. Standard form means just a normal number. Okay, decimals included. That's what standard form means. All right. Example 1 is 4.17 times 10 squared. That's not standard form. That's actually in scientific notation. What?
I think I know what it is.
What do you do?
Alright. You add 2 zeros on the right of the decimal, and then put the 1 and the 7.
Almost. First of all, what's 10 squared? 100. And when you multiply something by 100, what does that do to your decimal? Yeah. So what this is doing, you're just multiplying by 100. So you're going to move the decimal 2 places to the right. Here's the key. Exponent is positive. Move right. If the exponent's negative, move left. Alright, so the answer is 417. That's a standard notated number. Standard number. 417. Yes?
Okay. I get this not a 10, and it's like 7 to like 4th power, and it doesn't equal 100 or something. What do we do?
Then you just have to multiply it out. Whatever 7 to the 4th is, take that number times 4.17. You just have to do the long multiplication process.
Okay.
This is just specifically talking about powers of 10, what it means when you see it in a book, because you have a lot of scientific notated numbers. This is, instead of writing some long decimal number or some huge number that's on your calculator, too big to fit on your calculator, we needed a way to shorten it up. And that's what scientific notation is. Trying to shorten how many numbers you're actually writing down. Something's 135 trillion, 516 billion, 419 million, 217,001. Instead of writing all that, it'd be nice to have a way to write it in a shorter fashion. So that's what scientific notation does. It makes it in a shorter, puts it in a shorter form. All right, so now let's do write in scientific notation. And this is where this is a tool that you need to put in your brain somewhere to help you manipulate how a number looks. And there's a bunch of different things I need to show you. So, rule 1. Must only have one number left of the decimal. Can't be 0. That means one digit left of the decimal. It can't be like 55 point something. That would be 2 digits left of your decimal. Only one digit left of the decimal. That's the first rule. Okay? Rule 2. For it to be in scientific notation, it must be multiplied by a power of 10. Now we've been talking about exponents. Exponents are powers. So that's what we're talking about here. So you got to have two things for it to be in scientific notation. If it doesn't meet those two requirements, it's not in scientific notation. I'll show you an example of why that's important here in a minute. Example 2. I was going to do another example on that. Let's do example 2 here. You don't have to write this down if you don't want to. I want to make sure we got this part. I forgot to put this down. 376 times 10 to the negative 3. What's that answer going to be?
Wait.
If you're going to write it in standard form. Give everybody a chance to get that. 376. First of all, where's the decimal? After the 6, because if you don't see it, it's always at the end. All right. Good.
It's 0.376.
Yeah. But it's negative. We move it to the left 3 places. So 0.376. All right. So I think everybody doesn't have a problem with that. Yeah.
I said you can't have any. I said you have to have another.
Only if you're putting it in scientific notation. This was still a standard notated number. I forgot to show you that example. Okay. So going from a number here, which is not scientific notation, it's just a number multiplied by a power of 10. But I want it written in a standard notated form. All I do is actually figure out what the answer is. Okay? So this is a standard notated number. That's not a scientific number, scientific notation. It's not scientific notation. These are for writing something in scientific notation. So example 3 is what we're working on. All right, 6,738,004. I want that written in scientific notation. So Hannah, rule 1 says what? Right, where's the decimal on this number? Yeah, this is a standard notated number. There's the decimal. Where does the decimal need to be?
6 and 7.
Yeah, right here. So 6.738004. That's rule number 1. What's rule number 2?
It has to be multiplied by 10.
Yeah, you need a times 10 here. Now the question is, what goes in that position? And here's what's important and where some of you struggle. This decimal in my answer is affected by what I'm multiplying by a power of 10, right? Yes? So what is this power of 10 going to do to this decimal to get it back to where it was? It's got to move it to the right, which when we move it to the right, that's a positive. So this exponent better be positive because it's affecting this decimal. Don't look up here and say, well, this decimal moved to the left. Well, I'm not multiplying that number by a power of 10. I'm multiplying this number. You understand? Okay, so this exponent better represent what this decimal is doing. Hannah.
Exponent 6.
Okay, so it goes 1, 2, 3, 4, 5, 6 to get back there. Positive 6 will be that answer. How are we doing?
That's what we're trying
All right.
to find.
What's that?
That's what we're trying to find next.
You're trying to tell me on this example what this number is in scientific notation.
Oh, okay.
Let's do another one. Okay, example 4. 0.304503. Obviously, this will go the other direction. So, Bethany, is the decimal in the correct position?
No.
Where should it be?
93.
Okay, if you put it here, this number will be 4,503, right?
Yeah.
What's rule number 1 say? Only one number, one digit left of the decimal. If you put it here, how many digits are left of the decimal then? 1, 2, 3, 4.
4. That's because of 4.
Yes, between the 4 and the 5. All right, so now we're getting somewhere. So 4.503 is where rule number 1 takes us. Rule number 2 says I got to multiply it by a power of 10 raised to some power. So, and again, this number tells you what you're doing with this decimal, not this one. Okay, so Bethany, what does that decimal need to do to get back to here?
I don't know.
Okay, so in your answer, the decimal's right here, right?
Still has to be 4 o'clock.
1, 2, 3, 4. In what direction?
Right. Your left.
Yeah, from here, it has to go left. So it's going to be positive or negative. Stop telling her. That does not help
I
her.
was saying to myself.
That's why you went like this. Negative. Negative. You got to twitch when you talk? Yeah, it's negative. Because you're going to the left. This has to go to the left 4 units.
I just didn't know how you got like the painting in the circle thing. I really didn't get how to do that.
Okay, you got it now?
Not really.
Okay. Do one more.
I don't understand.
Wait, so left is negative and right is positive.
This 10 is going to affect this decimal.
Like, I don't get how you got the 4.
Oh, how it got right here? Okay, rule number 1 says there can only be 1 digit left of the decimal. She wanted to put it right here, which would mean there's 1, 2, 3, 4 digits left of the decimal. But there can only be 1. So if I put it in front of the 4, there aren't any digits to the left.
Okay.
If I put it here, there's 2 digits to the left. Got it now?
Yeah.
All right. Should we do another example?
Yeah.
All right, let's see. How about everybody just write these down? 1, 2, 3.005. 123.005.
Move your head.
That's all right. So, where's the decimal need to be, Bethany?
Behind the 1.
Between the 1 and the 2, right? So this is 1.23005. And we got to multiply by a power of 10. Anna?
Times 10 to the power.
To the 5th power? Positive 5?
Yes.
Positive 5 means what? Means that decimal is going to move back to the right 5 places. Well, these two numbers won't be equal then. See this equal sign? You have to make this equal this.
You have to move it over 2 places to the right.
This one will have to move 2 places to the right to be the same as this one, right?
Yes.
Okay, so what's that going to be then? Positive 2.
I got a question. Why wouldn't that be negative? Didn't you move to the left?
No. In order for this to be the same as that, what does this have to do?
Times to the right.
2 places to the right to equal this. That's why that has to be positive 2.
Did we start off here? That number or that number?
You started with this one. But if you look at this, look at your answer. Here's what I always tell my students. You got to look at your answer and tell me if you went backwards, if you went to the original problem, would it be equal? What is this going to equal? What does that 2 do to this? And then would that be equal? Okay, then you know you did it right. So once you're done, look at your answer and say, okay, what would this be like if I actually had to make it into a standard notated number? And if you get the original number, then what you did was right.
So the whole thing you're trying to do is get what's on the equal sign to match what's on.
Yes, that's why it's equal.
Okay.
Okay? All right, one last thing. Example 5. 4 times 6 times 10 to the 3rd multiplying. Yes.
I think I know how to do this.
Okay, how to do it?
You do 3, 10 times 10 times 10 times 3 times 3 times 3.
No. That will work. It will work, but I don't want you to do that. Yeah.
Do the scientific notation. So take the 6 and the decimal point back to 6 and times to the right.
Okay, that will work too, but that's not what I want you to do. Okay, here, look. I'm trying to show you how to keep things, or a shortcut and to keep things in scientific notation. First of all, is it all multiplication that's up here? Besides the exponent between all the numbers. So if it's all multiplication, do I really need the parentheses?
No.
Okay, so really what I have is 4 times 6 times 10 to the third. Can I take 4 times 6? Alright, so now it's 24 times 10 to the third. Is that number in scientific notation?
So much easier. Yes.
No.
So much easier to what?
Like, understanding how to work out like all that stuff.
Why is it not in scientific notation?
Because there's two decimal places, or there's 2 places in front of the decimal.
Yeah, you can only have 1 digit left of the decimal. We have 2. Now, you must make 24 into a scientific notated number. So what is 24 in scientific notation? 2.4 times 10 to what? Again, what are you doing to this decimal? What are you doing with this decimal to make it to the right ones? Yes. That would be positive 1 because this number is affecting this decimal, not that one. Remember, these have to be equal. In order for this number, 2.4, to equal 24, don't have to multiply it by 10 to the first power?
Yes.
Okay, that's when you know you did it right. Because this affects that decimal, not this one. Stop looking at the original number. Look at what you're doing here. Now, we're not done. This is only 24. Aren't I supposed to take 24 times 10 to the third? Now you have what we did yesterday. 2.4, don't have 2 like bases in multiplication. What do I do with my exponents? When you have like bases in multiplication, you add them. What's 1 plus 3? 2.4 times 10 to the fourth is what that answer is.
Is what?
This equals that.
Do we need to figure out that one?
No, you're done. I wanted this written in scientific notation.
So,
So when you actually do this, and let's say this was in scientific notation, you'd be done. But when you multiply those 2 numbers together and it's not in scientific notation, you gotta first put this number in scientific notation and then apply the other power of 10 to it. Step 1, multiply these 2 numbers. Rewrite the problem. 24 times 10 to the third. Step 2, if this is not a scientific notated number, you must make it a scientific notated number. Okay? If it's not scientific, is 24 in scientific notation? Okay, then you must make it scientific notation.
But how do you know how to move it? Like, what to move
Well, that's on, you told me right here that this was not scientific notation, and you told me that it needed to be between the 1 and the 2. That's how you do it. You look at this number right here. If that's not scientific notation, make it scientific notation. So you would move the decimal between the 2 and the 4. Well, you can't just move it because you want to move it. You got to times it by a power of 10.
So it's the same as
Yes, but then you also still have to have this 10 to the third here. Thank you. Okay? So then once you have this, then you have yesterday's assignment, and you add the exponents. Then you're done.
So you don't have to multiply.
Multiply these 2?
Yeah.
No, because your instructions say put it in scientific notation. If they say put it in standard form, then yeah, you're going to figure this out. They're going to say put it in scientific notation. Yes?
I thought we were told never to write PIMDOS, the P and the
You're not.
Then I thought French just kept first one, I could do the same sign, but she's
You're not taking and doing 10 to the third. What we're doing is we're learning how to manipulate the decimal position. I'm not asking you what 2.4 times 10 to the 4th is, because if I did, you would say you would actually do 10 to the 4th first, and then multiply by 2.4. If you did that, you'd be giving me standard form. I'm not asking you to give me standard form. I'm asking you to manipulate this in a way that this is in scientific notation. Yes?
So it needed 1, but if you move it to the left, I thought the decimal to the left would be negative.
Yeah, if I'm moving this decimal, I'm not moving this decimal. I'm moving this decimal. I'm moving the decimal in my answer, so that this number equals that number. If you put a negative here, what's that going to make this? When I multiply this out,
Negative?
it's going to make, no, it's not. It's going to move this decimal to the left, isn't it?
Oh, yeah.
So it's not going to equal that if I make that negative. So you got to get in your mind, what am I doing to the answer? Because I want it to be equal. If I make this the opposite, it's not going to be equal. You've got to make sure it's equal. Yes?
Was it
Yeah.
Yeah, probably more.
Yeah.